This is the first lesson of Unit 3, Exponential, Logistic, and Logarithmic Functions. Today we're going to talk about exponential and logistic functions. Let's start with the definition of an exponential function. So this says, let a and b be real number constants. An exponential function in x is a function that can be written in the form f of x is equal to a multiplied by b to the x. So what we should notice here is that we have a variable exponent and both a and b are constants. And a is non-zero, b is positive and not equal to 1. So let's talk about what a and b represent. The constant a is the initial value of f. In other words, it's the value at f of 0. This makes sense because when we plug 0 into the function, we're going to get f of 0 is equal to a multiplied by b to the 0, and we know that b to the 0 is 1, so we'll have a multiplied by 1 equals a. The constant b is the base of the exponential function. The way the exponential function is defined, remember, b is positive and not equal to 1. So, if a and b are both positive, then we have an exponential growth function. And we call b the growth factor. So when we have an exponential growth function, the constant b, which is the growth factor, equals 1 plus r, where r represents the rate of increase or growth. If a is positive and b is between 0 and 1, we have that we have f of x equals a times b to the x is an exponential decay function. And when this happens, we call b the decay factor. So the constant b, which is the decay factor, equals 1 minus r, where r represents the rate of decrease. Let's determine formulas for the exponential functions g and h, whose values are given in the table below. So the first thing to do when we write an exponential function is identify the initial value. So we see that when x is 0, g of 0 is 4. So that means that the initial value of g is 4. And then we also see that every time x increases by 1, the value of the function g is multiplied by 3. So we have the function g of x equals 4 multiplied by 3 to the x. And this is an example of an exponential growth function. Let's do the same thing for h. I'm going to label this the base. Okay, so the initial value of h is 8 because that's the value when x is 0. And we see that every time x increases by 1, we multiply by a fourth. So 8 is the initial value, and 1/4 is the base. So we'll write h of x is equal to 8 multiplied by 1/4 to the x, which gives us an exponential decay function. So now let's determine formulas for the exponential functions whose graphs are represented below. So again, first what we'll do is identify the initial value. Because the y-intercept is 0, 3, we see that the initial value is 3. So I can start by writing y is equal to 3 multiplied by b to the x. And then what I will do is plug in 2, 6 for x and y respectively. So I plug in the point 2, 6 by replacing y with 6, by replacing x with 2. Then I solve for b, I divide both sides by 2, and then I take the square root of both sides, which gives me b equals root 2. So I can rewrite root 2 as 2 to the 1/2, which is handy to do for writing this exponential function, and I'll show you why. If I replace b with 2 to the 1/2, x, then I can multiply 1/2 by x, which gives me x over 2. So I get 3 times 2 to the x over 2 as my exponential function. Now let's look at this example. Here my initial value is 2. And I have the point 3, 1. So I start by writing y equals 2 multiplied by b to the x. And then I plug in the point 3, 1 by replacing y with 1 and replacing x with 3. I divide both sides by 2. That gives me 1/2 is equal to b cubed. And then I take the cubed root of both sides, which gives me b is equal to the cubed root of 1/2. And I can rewrite the cubed root of 1/2 as 1/2 to the 1/3. Remember, cube roots can be written as exponents of 1/3. Square roots can be written as exponents of 1/2. So then I can replace b with 1/2 to the 1/3, which gives me y equals 2 multiplied by 1/2 to the 1/3 to the x. I then multiply 1/3 by x, which gives me 2 multiplied by 1/2 to the x over 3. And what I'll do here, I'm going to take these parentheses off. Here, I'm going to write it like this.